Okay, welcome back to part 3 for 10.4. So, how does the convolution help us? Well, it helps us find Laplace transforms and inverse Laplace transforms. Um, so, just to show how this compares with what methods that we've done before with partial fractions, let's do a problem both ways. So, let's start off with the partial fraction way to find the inverse Laplace transform for the quantity 1 over the quantity s squared times s minus 3. Well, we notice that we've got repeated factor in the denominator here, so we'll need s and s squared and s minus 3. Now, each of them, the factors itself, not counting the repeating, is a linear factor, so the numerators need to be constants. Now, if we do our partial fraction work and get a common denominator, and then if the denominators are the same on an equation, then the numerators must be the same. So we'd have to get a times s minus 3 plus b times s minus 3 plus c times s squared. And you could multiply this all out and do 0s squared plus 0s plus 1 if you wanted to, kind of like what we did earlier. But this one is easy enough that maybe I could just do a simple substitution. Let's suppose that s is 0, for example. So if s is 0, I put that in and I get 1 equals, that goes away, and so we'll have b times negative 3. So b is negative 1/3. Okay, let's try another good one. How about s equals 3? So that will take out this term and this term. And so we'll get 1 equals c times 3 squared, or 9. So c would equal 1/9. Now we've used all the good friendly ones. So we've got 0 and the 3. So we're now going to have to use somebody else. So let's try something like s equals 1. So if that's true, we've got 1 equals a times 1 minus 3. 1 minus 3 is negative 2, so that would be negative 2 plus b, which we know to be negative 1/3, times 1 minus 3, which is negative 2, plus c, which is 1/9, times 1 squared, which is 1. So we've got 1 equals negative 2a plus 2/3 plus 1/9. I'm going to rewrite that as negative 2a plus 6/9 plus 1/9, so that this together is 7/9. And if I subtract 7/9 from both sides of my equation, I will find out that 2/9 is equal to negative 2a. And if we divide both sides by negative 2, we find out that a is negative 1/9. Therefore, 1 over s squared times s minus 3 is equal to negative 1/9 times 1 over s plus b, but b is a negative 1/3, minus 1/3, 1 over s squared, plus c, which was 1/9, times 1 over, let's see if I can squeeze that in there, s minus 3. Oh, good. All right. And remember that our whole goal here was to find the inverse Laplace transform. So what we did was we did our partial fractions to break them down into easier to manage pieces. So the inverse Laplace transform for this guy, remember that the inverse Laplace transform for 1 over s is 1. So the inverse Laplace transform of 1 over s squared times s minus 3 is going to equal negative 1/9 times 1 minus 1/3 times the inverse Laplace transform for this guy, which is t, plus 1/9 times the inverse Laplace transform for this guy, which we learned recently is e to the 3t. So there is our inverse Laplace transform using partial fractions. So what are we going to do next? Well, to compare and contrast, we're going to solve this same problem. We're going to find its inverse Laplace transform, but we're going to use the convolution method. Okay. All right. So noticing that 1 over s squared times s minus 3 is the product of two known inverse Laplace transforms. So the Laplace transform of t is 1 over s squared, and the Laplace transform of e to the 3t is 1 over s minus 3. We can then use our convolution theorem, which says that to do our inverse transform, what we need to do is find the inverse Laplace transform for capital F of s, which is f of t, do the same thing for capital G of s, which is g of t, but not just multiply, but do the convolution of those two guys, where remember our convolution was an integral. Okay. All right. So what we need to do then is to do the inverse Laplace transform of 1 over s squared times 1 over s minus 3. That is going to be the inverse Laplace transform of 1 over s squared convolute the inverse Laplace transform of 1 over s minus 3. And we know that is t, and convolute e to the 3t. Okay. So, and if you wanted to, you could write this as we saw on the front page, e to the 3t convolute t. Okay. Whichever way you want to do it. So I'm just going to go ahead and we'll just go either way will work. So we're going to do, let's do, how about t convolute e to the 3t. Okay, so we'll have the integral of t times e to the 3, and in place of the t, I'm going to put t minus x, whoops, and this guy should have been an x. Okay, dx, so I don't mix my t's and tau's, and we're going to go the integral from 0 to t. Okay, so what do we have here? We've got the integral from 0 to t of x e to the 3t times e to the negative 3x dx. Okay, now x is the variable, t is acting like a constant, so we can factor the e to the 3t out front, and now we've got the integral 0 to t of x times e to the negative 3x dx. And we can do integration by parts. This one's easy enough. We can actually even do tabular integration. So I'm going to do tabular integration, which is just integration by parts several times. Okay, so here's my u's and here's my dv and his integrals. So we've got dv is e to the negative 3x. The antiderivative of that would be negative 1 over 3 e to the negative 3x. And then we would get 1/9 e to the negative 3x. And maybe I should write the 0 down here. That's a 0, not an 8. Okay. And so when we do integration by parts, we get uv minus the integral of v du. Okay. And so with our tabular integration, we're going to multiply these two terms with a plus, the next terms with a minus, and the next terms with a plus, but that's going to be 0, and any of these other guys are going to be 0. So we won't need those guys there. So we're going to get e to the 3t times negative 1/3 x e to the negative 3x okay? And then minus 1/9 e to the negative 3x, okay? Oh, I better put some square brackets on that. And we're remembering that we're evaluating that integral from 0 to t. So we're going to get e to the 3t times, let's stick the t in, we're going to get negative 1/3 t, make that negative look better, e to the negative 3t minus 1/9 e to the negative 3t. Okay, and then, so there's capital F of b minus, let's put in the 0. Ooh, that term is going to be 0, and then minus negative 1/9. Okay, and let's see what happens. So when we multiply the e to the 3t through, we'll get negative 1/3 t for the first term. E to the 3t times negative 1/9 e to the negative 3t would be negative 1/9. And e to the 3t times positive 1/9 is plus 1/9 e to the 3t. And if you're careful, you will notice that we got the exact same answer as what we got by partial fractions. So I'll leave it up to you to decide which way you like better. But the convolution is a handy tool to know and use.